All right, today we'll start dealing with angle addition. Once again, this is a familiar topic for you, something we did in trig class. We'll go a little bit faster, but should have some familiarity to the types of problems that we have with respect to trig angle addition. I will give you three of these. I will give you the three addition ones. You'll have to come up with the subtraction ones, but they'll be similar. We have multiplication here. We have multiplication between these trig functions. Okay. When you deal with sine, sine is sine of one, cosine of the second, plus the cosine of the first times the sine of the second. It's sine, cosine, cosine, sine. One of each in the expansion. And the signs here, with respect to sine, we have negative inside, we have negative here. When this turns into positive inside, we have sine, cosine, cosine, sine, and our plus sign also trails over to here. So if I have plus in here, I have plus on the outside inside with the expansion. Okay, plus and plus. Okay, when I deal with cosine, I have cosine, cosine, sine, sine. So we have cosine A, cosine B, minus sine A, sine B. Sine, cosine, cosine, sine, sine. Now with the cosine, if this is plus, this will turn into a minus. This is minus on the inside, that will turn into a plus on the outside. The tangent's a little bit more, but I still have all tangents here. The sine here, positive, will trace up to here, so the angles are either going to be tangent A plus tangent B, or if it's subtraction, tangent A minus B is tangent A minus tangent B. And then on the bottom, we switch from negative to positive of 1 plus or 1 minus tangent A times the tangent of B. I will expect you to know these. I will give you three of them. You will have to be able to expand the rest of them out. If I have the secant of A plus B, you can use your reciprocal functions, 1 over cosine of A plus B, and expand that out. Or if we look at the cosecant of A minus B, this is 1 over the cosine of A minus B. So you have to expand it out and put it over 1. Okay, so I will expect you, I will give you three of them. You'll have to derive everything else. We want to come up with exact values. Exact values. Well, what we've dealt with exact values before are two special triangles, a 30-60 and a 45-45 right triangle. When we have a 45-45, we have 1 square root of 2. When we have a 30-60, we have 1 2 square root of 3. These are things that we've dealt with already. It's what we dealt with all last chapter. If you need it, get your trigonometric guardians there. So what we can find exact values for trig functions are 30, 45, and 60. Well, when I want to find the exact values for a cosine of 15, there's no 1575 triangle that we can utilize. But you can utilize the two of the three values that we have up there, 30, 45, or 60, and come up with 15 degrees by either adding or subtracting. So if we were going to either add or subtract two of these values, what can we either add or subtract and come up with 15? So we can subtract cosine 45 minus 30, or if we wanted to, 60 minus 45. Does not matter. Here's our A, here's our B that we are subtracting. So we're subtracting out cosine, expanding out cosine A minus B. So try not looking above, but if you need to, that's fine. When I deal with cosine, it's cosine, cosine, sine, sine. Cosine, cosine, sine, sine. And the sine the negative sign turns into a positive, or if it's a positive sign, I turn it into a negative. So we can expand out cosine A times the cosine of B plus the sine of A times the sine of B. 45, 30, 45, 30. So looking at your triangle, what is the cosine of 45? Write it rationalized. I know it's 1 over square root of 2, but we want to rationalize that. What is the cosine of 30? So we have square root of 2 over 2. Cosine of 30, square root of 3 over 2. Sine 45, the same as the cosine. Square root of 2 over 2. And sine of 30 is 1/2. Orders of operations. Multiply together first. Square root of 6 over 4 minus or plus square root of 2 over 4. So we have square root of 6 plus square root of 2 over 4 is our exact value. Right sine of 75 degrees is two of those values, either added or subtracted. It doesn't matter if you write it 45 plus 30 or 30 plus 45. So we need to expand out sine of A minus, or plus, sine of A plus B. Well, I expand out sine, that's sine cosine, cosine sine. There's one of each in each section. And whatever my sign is here, my plus sign will also go down. So we have sine A cosine B plus cosine A sine B. 45, 30, 45, 30. Write your four ratios. Which will look very similar to what you just did on the first one. Combine them together. Multiply first and then add. Square root of 2 over 2. Square root of 3 over 2. Square root of 2 over 2. And 1 over 2. And we should come down to the exact same solution, square root of 6 plus square root of 2 over 4. And there is a property of trigonometry or geometry of right triangles. The sine of an angle will equal the cosine of its complement. 75 and 15 are complements. So these two are going to be equal. Now at the bottom, need to draw a picture, draw a picture, draw a picture. I give you angles, and the key is the sine is positive, the cosine is positive, here the tangent is positive, and the sine is negative. So you need to know the quadrants and where your signs are positive or negative. Well, everything in quadrant 1 is positive. If we look in quadrant number 2, if I would just do a quick sketch of a triangle, we have negative on the bottom, we have positive here, and we have positive here. So if I look, my sine will be positive, my cosine's negative over positive, So if cosine's negative, and my tangent's opposite over adjacent, so my tangent is also negative. Quadrant 3, we have negative, negative, and positive. My sine will be negative, my cosine will be negative, while my tangent will be negative over negative, so the tangent will be positive. So the tangent's positive, sine, cosine are both negative. And in quadrant number 4, my sine will be negative, my cosine will be positive, and my tangent will be negative. So if I take a look at my last one over here, my tangent's positive, my sine's negative, puts me into quadrant number 2 or 3. The first one, both of them are positive. So angle A will put us in quadrant num 1. Sine is 1 over 2. Our good old buddy Pythagoras will tell you that's the square root of 3. My tangent's positive, my sine's negative, which puts us in quadrant number 3. So the tangent is opposite over adjacent, 3 over 4, so we have a 3, 4, 5 triangle. Well, we have to check to make sure any negatives, both the negatives were 3 and 4. So we have negative divided by negative gives us a positive 3/4 tangent. Sine of A plus B, try to expand it out without looking up top. Sine, yeah, sine, cosine, cosine, sine, one of each. Sine, cosine, cosine, sine. And our positive stays with us. So we have sine A, cosine B, plus the cosine of A, times the sine of B. So expand out, or use your trig ratios. Sine of A what's cosine of B? What's cosine of A? What's sine of B? Sine of A, we have 1 over 2. Cosine B, negative 4 over 5. Cosine of A, square root of 3 over 2. Sine of B, negative 3 over 5. I suggest you don't cancel anything out, just rewrite it. Negative 4 over 10 plus negative 3 square root of 3 over 10. Because we're going to want to get a common denominator there. If I do some canceling before this, I eliminate my common denominator. So we have negative 4 minus 3 square root of 3 over 10. Expand out your cosine of A minus B. Try doing it without peeking. Okay, cosine, 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 sine, sine. They're both cosines, they're both sines. But my sign in between changes as it goes down when I expand it. So rewrite it. We have cosine A, cosine B. This is negative up here, so this will turn into positive sine A times the sine of B. Look at triangles, write your 4 ratios. And combine, multiply, and then add. cosine of A, 1/, oopsie. Cosine of A is square root of 3/2. Cosine B, -4/5. Sine of A, 1/2. Sine of B, -3/5. Combining -4 square root of 3/10 plus a -3/10. So we have -4 square root of 3 minus 3/10. Find the exact value. Bend the rules a little bit. We have 45 and 30. 5/4 is 45, 5/6 30 degrees. Expand out tangent A plus B. Once again, you have tangent on top, being either added or subtracted. We keep the sign the same. On the bottom, they're multiplied together. Change the sign. So we have tangent A plus tangent of B. I keep my sign here as plus to plus. On the bottom we have 1 minus. We change our signs on the bottom. Tangent of A times the tangent of B. A is 45, B is 30. So the tangent of A is 1/1, which is a value of 1. Tangent of B, tangent of 30, we have 1 square root of 3, which rationalizes the square root of 3/3. Then on the bottom we have 1 minus 1 times, once again, the square root of 3/3. The difficulty with the tangent is it will give us complex fractions that we have to rationalize. We can multiply top and bottom by a value of 3. So we're left with 3 plus square root of 3/3 minus square root of 3. Distributing out. If you give me that as a solution on a test, I'll give you every point except for 1. Need to rationalize this because we have a radical on the bottom. So once again, looking at a conjugate. 3 plus square root of 3, 3 plus square root of 3. On top we have the value of 9 plus 3 square root of 3 plus another 3 square root of 3 plus 3. On the bottom, the middle terms will cancel out. So we're just left with 9 minus the value of 3. We have minus square root of 3 plus square root of 3, the 3 square root of 3, they cancel out. Simplifying, 9 and 3 gives me 12, plus 6 square root of 3/6. And this will even cancel out even more to give me 2 plus square root of 3. Sine of x plus 5/2, which is 90 degrees. Expand out sine of your A plus B. Again, try to do it without peeking. Sine is sine, cosine, cosine, sine, one of each. and my positive stays positive. So we have sine A cosine B plus cosine A times the sine of B. Nice part about this is when I give you the 90s and 180s, you can click and collect in your calculator. So we're left the sine of x times the cosine of 90 degrees, which is, looking at your calculator, 0, plus the cosine of x times the sine of 90, which I can click and collect into my calculator and give me a value of 1. Which just gives me cosine of x. Four pi, 720. We can rewrite this as 1 over cosine of x plus 720. So now we're expanding out the cosine of a plus b. So try expanding it out. One of each. And my sign changes. All right, we have cosine, cosine minus sine, sine. So we have our x and 720. X and 720. And once again, when we have one of these multiples of 90, I can use my calculator and just click-y-clack in my calculator. Cosine of 90 degrees. What is the sine, or cosine of 720? What is the sine of 720? So we have the cosine of x times cosine of 720 gives me a value of 1. Sine of x, sine of 720 gives me a value of 0. So this takes me to 1 over cosine of x, which takes me back to the secant of x. If I put the process in reverse, I have tangent plus tangent, tangent 1 minus tangent times tangent on the bottom. So this will take me back to tangent of A plus B because I trace this sine along here. So we have the tangent of 5 pi over 9 plus pi over 9. 5 pi over 9 plus 1 pi over 9 is 6 pi over 9, which is tangent of 2 pi over 3. And 2 pi over 3 is 60. So we have 2 times 60, or 120. So going to my triangle, 120 degrees. $60, we have a 30/60, 1, 2, square root of 3, a negative with the 1, and my tangent will be opposite over adjacent, square root of 3 over negative 1, or negative square root of 3. We will continue to practice. My suggestion as you go through your homework, don't always sit there and just go directly back to looking at the formulas. Try to challenge yourself and pull the formulas out without having to play just to recopy. If you have to play peekaboo, that is fine. Play peekaboo. No big deal. Have a good day.